Hey everyone, it's Matt again with another video, and today we're going to be attempting to make a little assembly jig so we can get a little retaining ring onto this shaft. So regarding this little assembly jig, right now to get the ring on is a little crude. We have a little top shaft here, and the ring sits on here and it has to get manually forced down kind of thing. Push down the shafts, kind of sit onto the ring, and you can kind of see it here. Little ring indented in the shaft. This is actually one of the shafts for the ratio adapters, and these are the little tips and whatnot. And the reason we're looking to get this done is because these all do need the little rings, otherwise the tips all fall out. It doesn't really matter what size they are. They'll all just fit in. They'll all just fall out. And how they stay in is, so they have the one tang on the one side, right? However, the tang on the end that goes into the adapter are all the same, apart from a couple of random exceptions. So, like this one here is 104 square on one side and 172 on the other. So this fits in here, allows you to have a 104 square tip kind of thing. But like I said, without the retaining ring, it just flops right out. So getting that retaining ring on there a lot easier is something I've been kind of wanting to do for a while, and today I just kind of got fed up with it and going to attempt to do that now. So we'll pop on the Fusion 360, try to model something relatively easy. Basically we just need a little cylinder with a hole in it, but not with the right size. And then so what I can do, what I'm attempting to do really, is actually I'll got one of my rings here. I'll just kind of show you that. So really not the right size, clearly, but something the ring will stay on here, kind of thing, kind of midway through the top shaft, so it hangs. I want the shaft to go on here, something I can just slam down, and then pull off the little guide thing, and then have the ring seated onto the shaft. That's what I want to do ideally. If it's going to turn out this way or that well, I don't know. I'm going to be 3D printing it, so I'm going to have to maybe account for part shrinkage or whatnot, but we'll see what we can do. First things first is to actually design the part on Fusion 360. On Fusion 360 rather. So we will get that going now. So what we have here is a little cylinder we've made. Just a little cylinder. It's got a hole all the way through it. How big did I make this? I made it, actually I should probably flatten that up. 80 millimeters tall. I don't know if you can see that, but yeah, 80 millimeters tall. And the diameter of the the hole internally, let's see here. I made that, I believe, well, it definitely isn't 80 millimeters, that's for sure. I thought I made that to be like 7. Oh, maybe it's trying to go up and down, isn't it? Yeah. Try tilting that. Let's see if that works. I'm still kind of learning with Fusion 360. It's, like, I know it's, nah. No, I want that. Yeah, diameter. Okay, here we go. Let's see if I can move the camera here to kind of show you. Yeah, the diameter here, yeah, 7.1 millimeters. So we will, that's roughly the size I kind of was able to determine. So, yeah, this stuff is always a little finicky to me because I'm still learning with it, right? So, but making stuff like this easy enough. So what I will do now is export this into my slicer, so Prusa slicer, and we will see about the settings. Okay, so I got this imported into here. What I'm going to be using is a 0.6 nozzle. I'm going to use it print in PLA right now, and I'm going to go 0.4 millimeter layer heights just in draft mode, just because I have no idea, you know, what kind of adjustments I'll need to do to this or what. But yeah, should be relatively easy to print. Just a small infill, 15%. Actually, I can probably cut that down to 10 now that I think about it. Slice that now. See how long it's going to take. About an hour, give or take, which in hindsight is not that bad at all. It looks it's got, yeah, mostly hollow because, yeah, once I settled on sizing, I am going to make one that is solid out of the carbon fiber polycarbonate, just because it does go under a lot of abuse. But if this one works, it's not like I'm not gonna still use it. You know, I'll throw it away if it breaks or if it's not durable enough. But I still want to have one that's durable enough. So we will get this printing right now. Alright, so that printed here looks okay, and right off the top of the bat, it's too small, so there's definitely a little bit of a shrinkage with the component, or sorry, the material here. I did kind of try to widen out the hole a little bit, but yeah, no, it's just barely too small. Yeah, no, it's not gonna work. So let's make the hole a little wider and try again. Alright, so that printed okay. And this is the carbon fiber polycarbonate by Prusa. I need another video about it. I'll put it in the link below. Nothing too scientific, just kind of my own observations. Alright, now, the main question, does it work? So, what I want is this to be a little snug and then point through. And it does. It's good. Let's do it on both ends. This side's a little open. That's okay. So, the big question is, if I put it on the shaft here like this, what I want it to do is clear the aluminum piece and bog down a little bit past on the black when it fattens out and has a space for the ring to pop in. And it does exactly that. It lets the one pop in, but not the other. And that is just bang on for what I want. But does it work? So what I have here is a I won't bring them all over here. This one, does it have one? No. Okay. So I got a little snap ring. Kind of hard to see. Let's see here. Like so. So what I'm going to do, put the little thing on like that. Put the snap ring on. You have to make sure that the aperture for it, like the opening here, where the tang will go in, does not coincide with the cut in the ring. Otherwise, it's, well, part of the ring might go inside and you have to pull the whole thing out. So I always put it to the very back. Okay, so the way I intended on this working is you prep it like this, push this down, it seats it, and what happens is the top piece will float through. You kind of empty it out and continue on with the next. So it's the first time I've tried this, so let's see if it works. Let's try that one more time. Let's try that one more time. Okay, so well, there's something I didn't plan on. It goes over. Okay, yeah, well, I guess that makes a lot more sense now because its diameter is big enough that it just goes inside. Okay, so I guess I just need a different way than this, or maybe if this was shorter. Yeah, if that was shorter, it should, so I can just force it on a little more. Now, it's not ideal, but it is kind of pushing it down. And I think I'm going to just jam it up in there. Okay. So I think in theory it'll work, but it doesn't like sitting on the thing. Can I just snap it on like that? Yeah, because what I want to do effectively is just, well, you know what I'm trying to do. I'm literally just trying to put a snap ring on with a easy to poke down apparatus. I bet if this was tapered internally, it would work better. Yeah, because all it needs to do, actually no, like, well, I don't want to ruin this one piece though, because yeah, if I put the ring on it like so, yeah, it sits there, it won't go any further, but if I do this, it just kind of pushes. Well, now it doesn't. Well, this is the other side. Yeah, it's just the other side. And it's stuck in there. There we go. Okay. Huh. Oh, actually, let's try the red one, because I thought it was built too tight. And that might actually help this time, so let's try this. No, not even close. It just physically will not drop. Yeah, no, that ain't gonna work. Okay, so did it work? It did! Yeah, it worked. Put a tip in there. Hey! Okay, well, I'll put that over there, but can it do it again? That's the kind of the selling feature. Like, can it do it like this many times? Can it do it 50 times? Can it do it 100 times? Can it do it 1,000 times? I do not know. Kind of wasn't paying attention too much to what I was doing, so I think it was this end, and I just knew. Is this end? No, it must have been this side. Yeah, it must have been that side. Make sure the snap ring's on the other side. Well, what did I do? I clearly made it work. Okay. I think I just have to get an angle to it, because that one worked too. Try it again. Because yeah, like I said, like doing it once is fine, but can I do it 1,000 times? Because right now I'm not even using the little base thing here, so I put it in like this. It's sliding all the way in. Okay, so what I have to do is kind of hold it at an angle, push more. Come on, I did it twice. Come on. Yeah, did that one too. You know, like. Like it isn't working like I planned on it working, but it isn't exactly failing either. So I think, well, like it's not like this isn't working. Like it's because my whole grand plan was to just have something I can just go chunk, 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 right? Just kind of do one, slam one out, do one, push it out again, do one, put it out again, do one, put it out again, and then you can just sit there for an hour and have a couple hundred done, right? So let's see if I can do this just by it like this and this, putting it at an angle. Nope. And it's stuck. Where's my brass hammer? Alright, try. Oh, it's crooked in there and in the snap ring, so now. Oh, don't tell me I ruined it. No. Well, maybe. Genuinely, maybe. See if I can unscrew part of it. And okay, so let's see if I can push it out. Just need to get a dowel in my little thingy. Alright, got two of those things here. Got this in case it doesn't work. Pretty sure this won't. Yeah, no, it's not long enough and too fat on the one end. And that's made by Snap-on. Huh. Alright. That one ain't gonna work. Now, this one should. I really shouldn't smack on this. This is a drive tip for like a Freightliner. They're like 40 bucks, but yeah. It is what it is. Hey, that worked. And the snap ring's stuck in it now. They come out? Yep. And how did I put this in? Oh, right. Screw that back in, screw that. Okay, so pull this out of the way, take my hammer out of the way. Back to square one. Alright, push it down. Make sure that's out of the way. Hopefully this didn't get damaged. Use the other side. Yeah, the tolerance on this, it didn't shrink very much, but it did technically shrink. But the tolerance I'm looking for is in tenths of a millimeter. So by all means, it's very dimensionally stable, but for like tooling, you know, maybe not so much, because it shrunk down. Then I made it bigger with this one, but I might have made it too big. So we'll see here. So yeah, I think I ruined the tool, because now it's just kind of sliding in entirely. But it needs to, like, I don't know why this wouldn't, well, maybe not this wouldn't work, but there clearly is a way to do it, right? Because it just needs to be pushed on in there. I made 3 of them, at least, you know, like, made these 3, so I know it kinda works. But I need to fine tune it for some consistency though. Let's try it just without the thing. Can I push it this way? No. So yeah, I think I blew out the diameter when I kind of forced it in there a little bit. The walls are relatively thin because I didn't build this very sturdy. I was just mainly looking for fit. So it only has like 10% infill and like 1, maybe 2 perimeters kind of thing. So it's, you know, by no means that robust. Well, let's see if I can just do it this way by hand. Just kind of press it on the side, push, push, push. Jeez. Like, it's technically working. And yeah, got that one on. Looks a little off. Alright, there we go. Just the one little tail of it didn't press in all the way. Yeah, that one works. So I made 4, but it's weirdly delicate. Like, it works and it doesn't work. It works and doesn't work, but it's super close though. All right. I wonder how I can fix that. I wonder if, well, I did make 4, so it's not like it, you know, was a waste. Yeah, no, made the red one. It was too fat. Or, no, sorry, it was too small because it shrank. And just shrank just enough. It shrank like maybe 0.3 of a millimeter, which is not much, but when you're doing like if I was pushing something in that was like 1.5 inches wide, it wouldn't matter. But, you know, when it's, you know, the diameter is 7.1 millimeters kind of thing, then, you know, I guess that's when the diameter of these matter. Yeah, so semi-successful, I would say. I got one that's no good and one that is sorta okay. I made 4 of them, so it's not like it was a total waste, but it wasn't. Yeah, so I don't think it was really a waste. Got one. This one's in red PLA. This one is in the Cement carbon fiber polycarbonate. Yeah, so I was lucky enough to get some of this. So it's a shame to kind of throw this kind of in the trash. Well, I won't throw it in the trash. I might be able to make it work. Like, I don't. If this was metal, I would just sleeve it, but I'm not gonna do that with plastic. But yeah, so like I said, not a success, but I wouldn't call it a failure either. Like I said, I made 4 of them. I do think I did kind of damage this a little bit by trying to force it in. But like I said, it's only got like a 10% infill and 1 or 2 perimeters, so it's not exactly made for like abuse. Just wanted to get something in for fit. But yeah, that's my attempt at making a little tooling jig for this. I'm of course not giving up. I'm gonna clearly keep going and trying some more. Yeah, so I guess that's it for this video. If you like what you see, you have a question, leave it in the comment section below. As always, like and subscribe, and until the next one, have a good one.